Hi, my name is Konrad Kurzynowski, and for my CS341 Final project, I decided to talk about Prolog, a logical programming language. Prolog is a very organic language. By organic, I mean that coding in Prolog seems to be more like a conversation that you're having with the person next to you than it is writing hash tables in C. The language can be basically divided into two main portions, facts and queries. Facts are very similar to databases in SQL. However, facts are more complicated in nature. Unlike databases, which hold raw data, facts can actually show relationships of different variables between each other in a single program, which is what makes Prolog so powerful. And queries in Prolog are basically the same thing as they are in SQL. You just tell the program what you want and it goes ahead and generates the output desired. Facts in Prolog are statements or relationships that equate to true. Every statement or relationship starts with a lowercase letter and ends with a period. They can contain one or more arguments, and they're all saved to a .pl file. So an example of a fact could be like the grass is green or the sun is shining. An example of a relationship would be Tom catches Jerry or Jerry escapes Tom. Building on top of facts, we have rules. Rules allow the language to provide a conclusion if certain criteria are met. Looking at lines 5, 6, and 7 of the code, we see that X is a parent of Y if X is a mother of Y, or X is a parent of Y if X is a father of Y. Lastly, we have X is a grandparent of Z if X is a parent of Y and Y is a parent of Z. Notice how the comma represents and also notice how the two separate rules for parent of XY are interpreted as an or. So a parent of XY can be the mother of XY or it can be the father of XY. Queries in Prolog are pretty much the same thing as queries in SQL. The only thing is that instead of querying against the database, you're querying against the facts and the rules in the .pl file. The language will respond with an answer such as yes, no, or a variable that you wanted to find. So an example of a query in Prolog is on the right. So you start out by typing in a question mark followed by a dash, and then you can enter a relationship to see if it's true or not. So for example, we have is Julie a mother of Bill? And on the left we see that Julie is a mother of Bill is a fact, so the language responds with a yes. The second query we have is Patrick a father of Ryan? If we look at the facts on the left, we can see that Patrick is a father of Bill and is a father of Jane. However, there's no Ryan, so the language will respond with a no. Lastly, we can ask the language for Julie is a mother of who? And the language will go ahead and first find Jane, since it's the first fact listed. And if you just hit enter, it'll end the query. If you type semicolon and then hit enter, the language will continue to look for other children of Julie. So in the following line, we have Julie is a mother of Bill, so the language also returns Bill as a variable. For the demo portion of my presentation, I will be using an online IDE called Swish, which lets me execute Prolog code. So on the left here, we have our facts and our rules, and in the bottom right, we have our console, which lets us execute our queries. So our first query will be, is Alice a mother of Leah? At this point, we're expecting either a yes or no answer. So when we hit run, we see that the answer is true because the first fact that we have is Alice is a mother of Leah. But what happens if we go ahead and replace one of the names in the relationship with a variable? Then the language will go ahead and find that variable for us. So in this case, Alex is the father of only one child, which is John. So we got John as the answer. We can continue to replace both the names in the relationship with variables to get a complete list of names in that relationship. So we should get Alice, Leah, John, Julia, and Alex and Alberta. So for the first one, we get Alice, Leah, then we can hit next, get John, Julia, and then we can hit next again to get Alex and Alberta. This window also lets us execute our rules. So if we go ahead and ask who is the child of Alex, we should get two answers, John and Alberta, because Alex is a father to John and Alex is a mother to Alberta. So if we go ahead and hit run, we get the first answer, John, and then we should get the second answer, Alberta. Cool. Lastly, we can use our final rule, the grandparent rule, to see if there are any grandparents in the list. So this is useful because when you have a huge file with tons of different facts, you don't ever have to do this manually. All you do is you make a rule for these facts to be true, and then you put it in a query, and the language will go ahead and tell you know whether it's true or not. So if we go ahead and hit run, we see that Alex is a grandparent of Julia, and if we go ahead and consult our facts, we see that Alex is a father of John, and John is a mother of Julia. So, therefore, Alex is a grandparent of Julia. However, we still have an option here called next, which returns false. That means that after we got the first result, the language didn't know yet if there was another grandparent. So it gave us the option to look for another query, and when we go ahead and ran that query, it returned false. And this concludes my presentation of Prolog. Thanks.